Okay, hi folks, it's day one of unit 4, a nice small unit again, a rather quick unit on functions. We're going to start with the definitions of domain and range. The domain of a function or a relation are the set of all x values. The range is the set of all y values. This is sometimes referred to as the independent variable, and then this one is the dependent variable. But usually you just think domain are the x's, range represent the y's. And something is a function if it's a set of x, y ordered pairs where no x repeats. So it's a function if all the x's are different. It is not a function if one of the x's is repeated. And then there's a one-to-one function and an onto function, which are particular types of functions. So if you look and say, do any of the x's repeat? And the answer is no, it is a function. They may ask you, is it a one-to-one function? A one-to-one function is where no y's repeat as well. No y values repeat. And then an onto function is a function that utilizes or uses all the y values. This onto function, we're going to have to discuss a little bit more in class, and I'll be a little bit more clear about that when we go through our classwork next time. So there's some functions where they ask that question, sometimes they do not, so it doesn't apply to all of them. So our main idea today is getting used to the idea of domain and range and answering the questions, is it a function, is it one-to-one, and is it onto? So let's just go through some examples. My first examples are just some ordered pairs. The first one here, this 1, 5, 3, 7, 5, 10, those are just 3 ordered pairs. Now over here I wrote finite sets. Finite means there's a particular number of ordered pairs that you can count. There's 3 elements in this relation. So it's a finite number, just 3. So let's go ahead and list everything that we have to list. What about domain? Domain, we said, just represent the x values. So our x values are 1, 3, and 5. It's just grabbing the x's. They get written in the set notation with those little curly braces because they're all just x values. That's our domain. Our range are the y values. So our y's are 5, 7, 10. So again, I just grabbed these for my x's, and then I grabbed these for my y's, and that's it. And then to answer the question, is it a function? Is this a function? You just look at all the x's. Are they all unique or all different? Yes. Do any of them repeat? No. So my answer here is yes. This is a function. And if we want to answer the one-to-one question, we look at the y's. Are all the y's different? Yes, they are. None of them repeat, so it is also one-to-one. Our second example is something called a mapping diagram. And it's just a different way that they can show you ordered pairs. So this ordered pair is 1, 2. This one is 2, 6. 5, 4, 9, 8. So the arrow just represents, this represents x, or the independent, this is the dependent. It's just, you could write them out in ordered pairs if that would look better to you. So if you would prefer to write them out, 1, 2, 2, 6, etc., and then do just what we did in example 1, you can write them out. I'm just going to grab the domain just from the circles. So my domain here is 1, 2, 5, and 9. Those are all the x values, or basically the first elements. My range is going to be 2, 4, 6, 8. The question about is it a function, are all of these unique? Meaning, are any of them used more than once? No, they're all different. 1, 2, 2, 6, 5, 4, 9, 8. None of them, it doesn't go 9, 6, 9, 8. So it's yes for function. And it's also yes for 1 to 1, again, because all the y's are different. No repeating values on the y's. All right, we're going to scooch up a little bit. I've got 3 more for you. You might need to pause here to copy those down. So I can answer the domain and range question rather easily. Domain is just listing the x's, range just listing the y's. But what I'm most interested in here are the function questions. So let's go ahead and list domain and range. My domain for this example is just 3. There's only one element that's in there because all of the x's are 3. You don't need to list it 3 times. My range, though, the y values are just 5, 6, 7. The question, is it a function? Are all these x's different? No, they are not, so my answer here is no, it is not a function. And if it's not a function, it can't be a one-to-one function because one-to-one is a particular type of function. So if you answer no for the function question, you don't even need to continue, you're done. You don't need to finish asking, oh, what about the y's being different? Because it's not a function to begin with. All right, our second example here, our ordered pairs are 1, 2, 3, 4, 5, 6. So my domain, of course, will be 1, 3, 5. My range will be 2, 4, 6. The question, is it a function? You're looking at the x's. Are they all different? Yup. So the answer is yes, it is a function. The question about one-to-one, are all these y values different? Yes, they are. So it's also yes for one-to-one. And then our last example here, 1, 2, 2, 2, 3, 2. Domain will consist of 1, 2, and 3. Our range, the y values, will just be the number 2. Again, you do not need to put it in there 3 times. The function question, you're looking at the x's. Are the x's all different? Yes, they are. So the answer is yes, it is a function. For one-to-one, you're looking at all the y's. Are the y's all different? No, the y's repeat, so my answer for one-to-one is no. All right, so those are examples of finite sets where you just have a couple ordered pairs and it's very easy to look at the numbers and decide if they repeat or they do not. They may also give you something different, which is an example like this, which is a graph. So instead of just having a couple ordered pairs, they're talking about this entire graph and they ask you those same questions about domain, range, function, and one-to-one. All right, again, domain, remember, are the x values. So what you want to do is you want to take your pen and start all the way on the left and go like this and then read that x value. So this hits at -4 and then all the way over here to 7. So the x values are the furthest left and the furthest right. You're reading where it lines up on the x axis for domain. Because it's not just 4 and 7, but it's all the points in between. So you've got 2 options here. You can use the interval notation. Interval notation would look like this. Because at -4 it was an open circle and at 7 it was a closed. Or, if you prefer, you can use set notation, which will look like that. And then for range, what we're looking at is our y values. So again, we're looking for the lowest number up to the highest number. My range will run from -3 up to +6. And then again, if you prefer the set notation, it would look like that. The question, is it a function, is answered by that vertical line test. You may remember this from Algebra 1. What we did was we drew a line up and down through the graph, and if it only touches one time, then it is a function. So my answer here is yes, this is a function. For the one-to-one question, you draw a horizontal line. So going across this way, would it always hit this line only one time? Yes, it would, so this is also yes. So that horizontal line test versus the vertical line test, I think you saw the vertical line test in Algebra 1. I think the horizontal line test may be new this year. All right, let's do one more. Again, when you're looking here, and we're going to list domain and range, for domain you just want to read the x's. So you want to Drag your pen sideways from the left, and as soon as it runs into the graph, that counts. So this is at 0, and it would go all the way over to 5. So the x's run from 0 to 5. I really prefer the interval notation because I just think it's easier to write. Range here is running from 2 all the way up to 10. It's just the low number to the high number on the range. So let's write that down in case that's easier for you to realize. Low to high on the range, left to right on domain. Again, that question, is this a function? If you draw an up and down line, a vertical line, it will hit this graph twice. So my answer here is no, it is not a function. And then again, you do not need to answer the one-to-one question if you answer no for function. All right, right below here, I just jotted down vertical line test and horizontal line test. If you need some notes here, I would write it's an up and down line. If it touches once, only once, then you answer yes, it is a function. If it hits more than once, your answer is no. This is the test for function. And then this is the test for one-to-one. So again, now it's a sideways line. I guess sideways is the word. Line. Again, touching once only. Touch once means yes, it is one-to-one. If it touches more than once, then your answer is no. All right, we have just one more sheet of notes. So they can give you a finite set, they can give you a picture, or they can give you an equation. So if they give you an equation like this, you have to make your own sketch. And then again, read domain and range, and is it a function, is it one-to-one? Here I've given you an example of a parabola. I'm assuming most of you would throw it right into the graphing calculator and get a little sketch. It doesn't have to be perfect on graph paper. Of course, it's the frown because of the negative here. It crosses at 3, so I just made a real generic sketch. And then let's go through our process. Domain is left and right. A little bit different here because this has arrows and it goes forever and ever down and down. And of course, if it keeps going down, it's also going to keep getting wider and wider. So is there any way for you to get all the way left or all the way right if this keeps extending out? No, it goes forever and ever in both directions. So this domain is actually negative infinity to infinity. Another way you can write that is this, which stands for all real numbers, or this, which stands for x is an element of the real. These are 3 different options to write the same thing, infinity to infinity. But range is not infinity to infinity. It goes forever down, so I can't find the lowest spot, but it does have a stop spot of 3. So my range runs from negative infinity to positive 3. Because those are, again, the y values. Is it yes or no for function? Does it hit only one time for function? Yes, it is a function. That's my vertical line test, if you want to remember it was from that. But it is not one-to-one because if I draw a sideways line, it would hit 2 times. So it's no to one-to-one. And that again is my horizontal line test. Second example is just a line, y equals 1/2 x plus 4. It's a line that extends forever and ever in both directions. So if it's going out to the left and out to the right, up and down in every direction, the domain here is all real numbers. The range is also all real numbers. You still can write negative infinity to infinity if you prefer it. I usually do this just because it's a little quicker. And is it a function? Can you tell if that's only going to always touch once? Sure. Is it one-to-one? Yes, it is. So it is a function. And it's also yes for one-to-one. One more example, last one, absolute value. Again, you may or may not remember this from Algebra 1. The absolute value graph was like a V like this. But if you didn't know it, you would just type it into your graphing calculator and get the visual. Oh yeah, I remember it's a V. So again, domain is left and right, and this has arrows going forever and ever in both directions. So you can never get furthest left, furthest right because it extends. So my domain here, again, is all real numbers, or this, whichever you prefer. But my range is not all real numbers. There are never any y values down here. So for range, it starts at 0 and goes up forever till infinity. So this one is 0 to infinity. The function question is yes, because again, an up and down line would always just touch one time. The one-to-one question is no, because a sideways line would touch more than once. All right, so one more quick thing here and we're finished. We didn't really address the onto question. So this is a nice place for us to do that. This particular function is no for onto. And an onto function uses all the y values. There are y values down here on this part that the graph's never going to get to, right? The graph only happens in quadrant 1 and 2. It's never going to come down here. So since there's this big chunk of the y-axis with no graph ever, that's why this answer is no. When you look back at the line, is it going to hit all the y's, all the up and down? Even if I'm way, way down here, if I go over here, I would have a point on the line. So lines, the answer is yes for the onto. Because there's not this part of the graph where nothing happens. This goes up and down forever and ever. And then back to the top one, what about the parabola? Yes or no? Is there a piece of the y-axis that will never see values? Yeah, everything that's above here, right? All up here, there's never anything going to be up there. It's only going to go from here and down, but there's this big piece of the y that will always be empty of graphs. So this answer is no for onto. On day 2, I believe, we'll put a chart in your notes that you can kind of talk about in a general sense. Lines are always going to be yes, yes, yes. Parabolas are always going to be yes, no, no, that kind of thing because of the way a parabola looks, right? Even if it had been a smiley face parabola, it would not be onto because of this big chunk down here that's always going to be empty. It would not be one-to-one because it fails that test. It would be a function because it passes this test. So for today, we're just getting used to the idea of domain, range, vertical line, and horizontal line to determine function yes or no. All right, the last thing I had for you was that little worksheet that I gave you. Block 1, I apologize, but the back came out really light. Whoops. And before I realized it was really light, that you had already left. So here are the answers for the first side. Actually, let's kind of scooch in and just show 2 at a time. So there's your answers on the first 2. Both of these graphs have arrows on them. I know it's a little bit difficult to see because they're just hand-drawn, which means they go forever and ever up and down. So you may want to kind of look at this one and investigate. And once you've copied it down and you think you have the idea, now would be a good time to pause if you want to try the bottom 2, and then I'll slide the answers for those up. Okay, here are your answers for the second 2. Here we have no arrows, which is why there's no infinities, right? Because there's a definite start and stop on the domain and range. I used the function, interval notation rather, in this graph pictures. And then on the back side, except for block 1, because you couldn't do the back, it was too light. For the second page, I used set notation. I will accept it either way, but I'm just showing you 2 different options. So again, pause now if you're working the back, and the answers will be shown shortly. I assume this was supposed to be an open circle, and then this one was filled in. I know that's a little tough to tell. And then the bottom 2 are here. Oops. So if you did the extra practice and you're checking your work right now, that'd be great. If you didn't quite get it and you're not too sure, we're going to be doing just tons and tons of practice again, and I'll show it in class again with the domain working left to right, range working low to high. The function question is an up and down line hitting 1 time means yes. function. 1 to 1 is a sideways line, and if it hits twice, the answer is no. And that's kind of it in a nutshell for lesson 1. Thanks, guys. We'll see you next time.